All right, so with our derivative review, a lot of this is going to be combining our rules. Okay, combining a lot of these rules that we have. One of the major things that y'all struggle with is chain rule with trig involved. So here's your first example. Example 1. All right, we're going to say this. You have that f of x is equal to secant sine of x. Okay? So this is a chain rule problem. All right, if you remember the chain rule, we talked about the candy. We talked about a blow pop. Mm-hmm. So there's really 3 pieces to the blow pop, isn't there? Mm-hmm. So over here in my thought bubble, okay, I got to think about my 3 pieces. So you have obviously the wrapper. Okay, you have the actual candy part. Yes, ma'am. Okay, you have the candy part, and then you also have the gum part at the end, right? So there's 3 parts to this thing. So the wrapper is around the whole thing, right? The candy's the stuff in the middle. Then you have the furthest thing inside, which is the gum. All right, so what I've got to do is I kind of got to dissect this function that I've got. So right here, this whole thing is the wrapper. All right, this is my wrapper. Okay, then what's the next most inside thing? Sine of x. So that would be the candy part. And then there's one last little thing. That's the gum. Okay? So in order to effectively apply the chain rule, I've got to take the derivative of the wrapper. Okay? Times. Now I got to take the derivative of the candy. Times the derivative of the gum. Okay, and I just work my way inside as I go. Okay, so let's think about how that would look. F prime of x. If I just take the derivative of the wrapper, all right, we know that secant, okay, over here another little thought bubble, secant of anything, secant of whatever that crap is, okay, goes to, its derivative is secant, same crap, tangent of the same stuff. Probably can't say crap in a video. Sorry. Apologize. Okay? So, that's what we're going to write. We're going to start out. The derivative of the wrapper is secant, okay, sine of x. Putting all that junk in there. Tangent. Same junk goes in there. I'm working like a robot right now. I'm going to my rule, and I'm only worried about that one piece of the rule. I'm not getting overwhelmed by everything else. I'm only looking at the small picture here. If you look at the big picture, it's going to overwhelm you. Okay? Now, I'm going to go another color here. Let's go blue. So I'm going to do the candy in blue. So we're multiplying this by the derivative of the candy. So the candy is sine x. So what's the derivative of sine? Cosine x. So cosine, again, of the same stuff that's inside. And lastly, I'm going to go green. Okay, we're going to go with the gum. So I'm going to multiply by the derivative of the gum, which is 1. Do I really have to write that 1? No. Okay? So that's your answer. All right? That one is the chain rule applied fully throughout that problem. Okay? All right, here's a second example. Okay, let's look at this. Y equals, we're going to go square root of x times ln of the square root of x. Okay? So we're going to try to take care of this one. Now, I know that this is it starts out as a product rule, correct? Okay, it's got product rule with chain rule applied to the second piece of the function. So product rule tells me this is my first function, this is my second function. Okay, D1. All right. So product tells me, what do I have? D1 times 2 plus D2 times 1. Is that correct? And D2 is going to be some kind of chain that's going to go on here. All right. So, good one to memorize. The derivative of square root of x is 1 over 2 square root of x. It's a good one to memorize for you guys. So that's easy for me to apply to D1. That's 1 over 2 square root of x times, what is 2? 2 is just ln of the square root of x. Okay. Plus. Now I've got to take care of, I have a little bit of a chain problem now. So if I'm going to come over here to the side. All right, if I'm going to chain rule ln square root of x, all right, this one has some chain properties, some chain things. All right, but this time it's only two things. Okay, you have your wrapper.
Wait, okay, Mr. McHale, okay, so why you didn't put the one?
All right, so that whole thing's a wrapper, and then the candy part is just square root of x. Okay, so then you got your candy part right there. All right, so really this one's only got two pieces. There is no gum in this piece of candy. Okay? Yeah, it's like a dum-dum. All right, so if we apply the chain rule to this for ln of whatever x is, isn't the derivative of ln, okay, isn't that 1 over whatever that stuff is? Yeah. Okay, kind of like that. So this derivative starts out as 1 over square root of x, all right, times the derivative of the inside. Well, we already have the derivative of the candy, which is square root of x. So that's 1 over 2 square root of x. Y'all see that? So this is my D2 part right here. That's D2. Okay, so this is 1 over square root of x times 1 over 2 square root of x. Okay, so that's D2. Now we need to times it by just 1, just square root of x. All right, so I've got it color-coded to help. Now it's just simplification. All right, so when I multiply those two red pieces together, you get ln square root of x all over 2 square root of x plus square root of x in the top all over 2, and can't we just say that's x? Square root times the square root is just what's under the square root. Okay, so we can just say x there. What is going on? Does that make sense? That's how I would leave it. Okay.
Wait.
All right, so if we look at this, like I said, this is kind of a nasty chain rule. All right. First thing I'm going to do, anytime your trig stuff is raised to a power, like it's raised to the 4th power, I'm going to rewrite it so that I can apply some power rule properties to this. So I'm going to write this in brackets. So tan of my stuff, 3x to the 3rd plus 2x. Close my bracket. All that's raised to the 4th power. Okay, so what I'm going to be able to do is I'm going to be able to apply the full chain rule. All right, like with the wrapper, the candy, and the gum. Okay, so right here, the wrapper is this whole thing. So you have something raised to the 4th power. Right? This is my wrapper part. So when you take the derivative of that, isn't that 4 all of that something raised to the third? Okay, so let's do that. Let's do that first. So that's 4 all of my something. All right, my calculus professor used to call it the blob of stuff. It's probably a better word than saying crap like I do. Oop, I said it again. Sorry, guys. All right. Now, we're going to multiply by, what do we say next? The derivative of the candy. All right, so my candy is tan, right? Tan is the candy part. So we got to know what the derivative of tangent is. Tangent is secant squared. Secant my tan. Secant. All right. So it's secant squared of all that stuff. Okay. Times. Now I've got to multiply by the derivative of the actual gum part. All right. What's the gum?
9x.
Yeah, 3x. So 9x squared plus 2. And I put that in parentheses so that you know that whole thing is multiplied by all that. Okay? So if you wanted to simplify that, some of y'all wouldn't want to. All right? Some people would distribute that 4 to the 9, like all the way, distribute this 4 from the front to the 9. So that's what? 36x squared plus 8. Right? And then all that is times. Okay? It's just kind of whatever you prefer right here. All right? This is a very, very long problem. I don't want to worry about all the simplification. I want to worry about, can you do the chain rule? Okay, that would be your answer. Now, this one's a pretty good one to do. So you got a product rule problem, and you also have something that's going to have chain rule in the second piece again. All right, so remember our product rule tells you that it's D1 times 2 plus D2 times 1, and we know that our D2 part is going to have some chain things in it, okay, because there's multiple functions in e to the cosine of 3x. It's really 3 different things. You got e to the something, you got cosine of something, and you have 3x. So that's 3 different functions there. So that one's going to have some chains linked together. That's why you call it the chain rule. Okay, so if we start this big old problem out. Remember, control what I can control. All right, the whole key to calculus, when I was taking calculus, that's what I would do. I would break it down into little pieces. All right, that's a life skill called compartmentalizing something. Right, like sometimes life overwhelms you. Right, you have so much stuff going on. What you got to do is you got to compartmentalize it and put certain things in their box, so that I can deal with certain little things at one time. Right? That's something that's helped me. Okay? So I'm gonna compartmentalize, and I'm only gonna take care of D1. I'll do that in blue. So here's D1. All right. What is D1? What's the derivative of 1 here? 2x. Ooh, man. Easy box right there. I feel pretty good. All right. Now we're going to multiply it by 2. Well, 2 is pretty simple. 2 is already in the problem. I'm just going to copy it down again. E cosine 3x. Man, feeling good about this now. All right. Plus, the dreaded D2. The dreaded D2. Doing that in purple here. Okay, so I'm gonna draw my little thought bubble down here. Right? D2. I'm gonna take care of the wrapper part. Then I'm gonna take care of the candy part. And then we'll look at the gum. Gum's usually pretty simple. Okay? So what's the most outside piece of our wrapper right here? E. So that's e to the something. Okay? What's the derivative of e to the something? E to the something. Good. E to the blob. So that's the first part of our chain here. E to the cosine 3x. Times. All right. Remember, we're multiplying all this chain together. We're linking them together like a chain is. Okay, now look at the candy. Isn't the candy cosine of 3x? So the derivative of cosine is negative sine of 3x. So that's my next little piece. Okay, times the gum, 3x. Well, that one's easy. That's just 3, right? Okay, so that's the D2 part. Now we had to go back and multiply it times 1, correct? And 1 is just x squared. Okay, so you could write this a little bit cleaner. F prime of x is I notice that they both have that in common. Do y'all agree with that? So I can factor out an e to the cosine of 3x. All right, what's left? 2x. Yeah, minus 3x squared and sine of 3x. Okay, now you probably could have factored out another x if you wanted to, but that will suffice. That gets the main idea here.